How was everybody today? First, I'd just like to thank everybody for taking time out of their busy day to log on and watch a little bit about cleaning your machines and keeping them up and running. So the topics we're going to go over today, we're going to do a brief overview on profile spray machines, followed by flatline spray machines. We're going to go through some of our more popular models, two Makor models, one Venjakob model. And then at the end, we're going to go through some pump and guns, which is probably the most critical component of keeping everything operable. So the topics we decided to talk about, we're going to go over basically filtration, so intake, exhaust, air, replacing filters, what happens when you don't replace filters, reclaim systems with cleaning belts on a couple of the models, how the fluid delivery and if there's filtration built into the machine for fluid delivery, along with flushing the machine properly. And then last, we're going to talk about some of the maintenance points, lubrication, oilers, water traps, those points. First machine we're going to go over is one of the profile machines. Machines in this presentation are from our lab in High Point, where we got the video and the footage from. Most of our profile machines are capable of running 6 guns. This particular model is can run continuous, has a belt with the cleaning group, but it's a little more advanced in exhaust than some of the basic models, but we'll go through that. So the FPC is a variable speed exhaust, meaning that it can ramp up or down automatically or manually. Some of the other models, the iRide, the CSP, they're fixed speed, but the filtration system still works the same. You have a set of dual layer exhaust filters. They're paper poly mesh. The exhaust is pulled from below the machine up through the filters and out through the exhaust ductwork. Intake filters on a machine are just a set of filters to help with any of the air that's being brought in from the top to be filtered. Second point we want to discuss is the part detection sensor. If overspray or dust gets on the lens of this particular sensor, it can create the guns continuously spraying or spraying when parts aren't entering the machine. And eventually you're going to have to clean it, otherwise you're going to run out of paint. So the second thing is important is to keep the pathway for the air free. If the pathway is wide open on some of the machines that don't have variable speed, you can have a problem where your spray pattern is actually pulled down so hard that it deforms around the part. So in those machines, there's a manual damper in the top of the exhaust cabinet that you want to adjust to restrict some of the air to be able to correct that issue. Also, when overspray bins become looking like this photo, you're going to lose exhaust. When you lose exhaust, the overspray is going to go with the motion of the part generally. So you're going to have overspray floating to the outside of the machine on the in feed and the out feed, which is going to get on the belt and framework or anything else around the machine. So it's important to replace the filters on a schedule. Next machine we're going to go over is the Q1. It's one of the most popular machines for the last, probably 13 years. Paper belted machine, single arm, standard width of 1,300 millimeters. And this machine can also be seen in our lab in High Point. So the airflow of this machine, we have 2 intake fans, variable speed. We have a single exhaust fan sitting outside the machine through ductwork. which is also variable speed. All of these speeds are adjustable by the operator. When we have intake and exhaust, this is what we categorize as a pressurized machine. Without intake air being brought in from the top, we have an extremely negative spray booth, which means that the air is having to brought in over where the parts pass, in feed and out feed of the paper belt. This can cause spray pattern problems, and it can also introduce a lot of extra dust in the machine that's not needed. So by adding the intake fans on the top, we have pressurization, and we add nearly neutral balance to the machine. Q1s that have been produced in the last few years also have a pressure sensor in the intake section and the exhaust section that will notify you when the filters are too dirty and need to be cleaned or replaced. Another filter that's commonly overlooked is a small filter inside the electrical cabinet. This filter is fairly easy to remove. Pop the cover off, blow it out, you can put it back in. This filter gets stopped up, particularly in summer months if the environment is dirty. It can cause overheating issues in the electrical cabinet. And there is an actual device which will cause the temperature alarm to go off if this is the case. Next, we're going to talk about the intake filters. So intake filters on this machine are roof mounted. There's 6 of them. With a wrench, you can move the little bone and they drop down. The media can be replaced after being cleaned 3 or 4 times. Usually with an air line, we start to develop holes, and that's when the media needs to be replaced. We also have air being blown into 2 side grates you see in the video, and that helps keep the overspray off the walls and keep the booth clean. Next point we're going to touch on is the exhaust filters. So like standard, this machine has 2 stages of exhaust filters. First stage, we traditionally use what we call the accordion or an Andrea style filter. They can take a lot more overspray than a standard just roll filter. So the life of the filter is much longer. You have to stop less and replace them. Below the Andrea filters, you'll see the second stage filter. This is a paper poly mesh filter, exactly like what we saw in the profile machine. If the first stage filters are maintained properly, kept clean, replaced, let's say, every 8 hours of production time, then the second stage filters should last 24 to 32 hours of production time. Here's a photo of the exhaust fan we touched on. Variable speed on the controller for this fan is from 50 to 100% speed. So a little trick I've done for years, this is a piece of Teflon tape. With the Teflon tape, we're able to see the draw of the machine. So on a pressurized booth, we can tell if it is negative or positive. So what we want is what you're seeing here, slightly negative, because once the gun begins to spray, they introduce a little bit of extra movement and air in the cabin. If we have too much intake air and our booth becomes positive pressure, this is the situation you're going to see here. The Teflon tape is blowing out. At this point, overspray is being blown out of the machine. So we want to avoid this situation. The opposite situation where we have too much draw from our filters, exhaust side, and not enough on the intake side is what you see here. This would be a negative booth. This would draw in dust and extra air across your part as you're spraying and can cause spray issues as well. So we want to avoid that. We want to try to stay in a neutral state like you see here. So it's slightly negative. Here you see on our display screen the ability to do the settings for the exhaust fan and the intake fan. It's variable in 5% increments. The next part we're going to touch on is the in-feed optical bar for detecting the parts. It's important that this stays clean as well, because any overspray or dust that builds up on this sensor will trigger one of the individual eye elements inside, and the machine will always try to run and spray in that particular spot. On this particular machine, because it's paper belted, which would mean that the belt and paper would run continuously as well. It's also important that the lens on these sometimes are not glass. They are a type of acrylic. So it's important not to clean these sensors with solvent. Doing so will cloud the lens, and in doing so, clouding the lens will ruin the filter. Ruin the sensor. So it will have to be replaced, because it will spray continuously for the full width of the machine at that point. So what we recommend is a damp cloth. You see in the photo here, even though our lab is fairly clean, this is what we cleaned off of the sensor by wiping it across. In some situations, you can use denatured alcohol if need be, but use sparingly. We have to protect the lens. Here you see a photo of the pneumatic system of the arm. So the arm of the Q1 has all the air lines connected. So your 4 trigger lines and your 4 atomization lines. So the head with the guns are removable, and how these make a seal are through these O-rings. It's important when removing the head that you pay attention and don't lose the O-rings or don't damage the O-rings. If you lose an O-ring, particularly on one of the ports for triggering the gun, then you will cause issues with the triggering. You have delayed triggering, or the gun may not trigger at all. So it's important to protect the O-rings. Some customers like to take a piece of cardboard and tape over them when they've removed the head that they're not using for a period of time. Another very important element that's overlooked very frequently is an inline filter. This machine ships with an inline filter. It's a small pencil filter. We'll see on the next slide. But this filter is extremely important, and if it's overlooked, will cause big problems. All the flow of the guns go through the small filter. So if this filter starts to plug up, then you're going to reduce the amount of coating output that you're getting. So if your millage is going to drop. If you're applying 5 mils and then an hour later, all of a sudden it drops to 2, first thing to check would be this filter. And here's a photo of the filter being removed. Some coatings have a particulate size that don't mesh well with this filter. It collects a lot of material and will build up frequently. So some customers choose to not use this filter. This machine is equipped with a 5-way valve on the arm, which allows us to have 3 fluid circuits and then 1 flush circuit. So with the valve turned to the L position, you're able to flush solvent through the line, through the filter, and down through the guns. So if you're changing heads on the machine, going from your head for clear to your head for pigmented paints, you can flush right there and then swap the head out and load the next color. It's important to remember that this does not flush the coatings from circuit 1, 2, or 3. So you have to do that manually from the pump. Another point is the linear bearings on the arm. This is probably the most crucial maintenance point, and it requires lubrication with grease from the grease fittings. So here's a photo. You can see a grease fitting here. On the opposite side, there's a secondary grease fitting. So you have 1 for each bearing. Factory recommends lubricating every 10 days with a couple shots of grease. They say 2 cubic centimeters of grease. That's about 3 pumps from a grease gun. The other point we want to keep lubricated is the track for the counterweight. So the counterweight rides up and down in this track as the wind-up motor winds the paper up. It's important to keep a little grit of grease on this track so it doesn't dry up and get any friction and tension that could cause jerking of the paper wind-up system. So you have a track on both sides, one here and one here. Third point is the water separator. And this is hid behind a panel where the main air comes in, so it's often overlooked quite a bit. In situations where the air supply has a lot of moisture or oil, this separator is in place to try to pull some of that contamination out of the air. So this needs to be checked probably monthly to see if you have any buildup in the bottom. If you have buildup in the bottom, you can hit the release mechanism on the bottom of this glass and release that water buildup. Okay, the next machine we're going to discuss is the K2. The K2 is a dual arm machine, meaning that instead of one arm in the middle, we have 2 on the side and the guns are pointing towards the center. It comes as the most popular, what we call a hybrid machine, which has a recovery belt and a paper belt. It's also available with just the recovery belt. So for the ventilation on the intake filters on this machine are located on the outside. They're a little more visible. Again, we want to keep these clean. We have an alarm that can go off if these filters become too clogged or if there's a filter removed and not put in. So we have a pressure manometer that will go off. Also, it's important on this machine because the intake air of this machine supplies cooling to the electrical panel because of its integrated design. So if these filters become stopped up to the point where really restricting the airflow, we can also have overheating issues in the electrical cabinet and set off alarms for that. Factory recommends clean the filters once a week, replace them once a month. The exhaust filters on this machine are identical to a Q1. You have a first stage that are accordion, second stage paper poly mesh, and exactly like the Q1, we have to keep them clean. So recommendation here is clean every break. So if it's 4 hours or 8 hours, check the status. These particular filters, a lot of customers like to take them and shake them and clean them out. We really discourage that. We would prefer that at the end of the shift, if you're running 8 hours of production, that the filters be replaced. Here's an example where the filters weren't maintained very well. Second stage filters weren't in place. First stage filters were just allowed for overspray to pass by. Because the exhaust fans are located right behind the overspray filter section, it's very possible you can collect a lot of overspray on the fan blades if the filters aren't maintained properly. Overspray on a fan blade can become imbalanced, can cause the fan blades to vibrate, which in turn is going to eventually ruin the bearings in the motor, and you're going to have to replace that. So we recommend yearly that these blades be inspected. If you have buildup, be removed from underneath the machine and cleaned out and reinstalled. So the optical sensor here is exactly the same as we saw on the Q1, the reading bar. And again, the important point is keep it clean and do not clean it with solvent. Clean with a damp rag or a damp rag with an alcohol-based product. This machine is also equipped with inline filters. This machine, we have an inline filter on each arm for each circuit. So as you see here behind this cap, when you unscrew this, you get the pencil filter inside of here. So again, it's important. Keep them clean. Check them daily, if not twice a day. On this particular machine, if one side stops up, then you're going to have one side of the machine spray more coating than the other side. So keep them clean or take them out. Your choice. The cleaning group of the K1 has seen some changes. Now it's a little more simplified. We have a bath system where we have two rollers that are sitting in the bath and clean the belt. The reclaim section that you see here is a carbide blade with a mopoline tray. So the carbide blade makes contact with the belt when the coating is being sprayed, and by gravity, it's allowed to drain down into a reclaim bin. Mopoline is a material is very similar to Teflon, so it's very important to try not to scratch it. So if you want to clean it, you can clean it with plastic materials, plastic blades, not metal. If the coating's allowed to dry in this, it peels off in one sheet. But over time, as it gets damaged and scratched, it'll lose some of its non-stick abilities. So here's a shot of the two rollers in the bath system. So a pump pumps solvent into the tray up to the drain hole you see here. From there, it's engaged, pneumatically engaged up against the belt, makes contact, and is how it's cleaned. The drains back into the main tank, and it's a closed loop system. You want to keep the solvent clean, replace it solvent about every 8 hours of use of the machine. Pull the cleaning group out at the end of production. The rollers lift out, wipe the rollers down, and make sure there's no buildup on the blades, and also make sure there's no damage or burring on the blades, which can scratch the belt. Just like we saw before, the lubrication points for the reciprocating arm, we have two, one on this bearing and one on the bearing that would be on the opposite side. About every 2 weeks, these need to be lubricated with 2 or 3 shots from a grease gun. Again, we have another water separator on our incoming air. The objective is to remove contaminants from the air, contaminants. Check monthly. Use the drain at the bottom to clean it out. Next machine we're going to discuss is the Venjakob Perfect. This is our largest machine in our lab in High Point. It's a dual arm machine. It has 2 cleaning groups, and it's the capability of running 24/7. So for filtration, we have 2 stages of filtration along with air curtain fans. So what you see here are the air curtain fans. They provide an air curtain over the infeed and outfeed of the cabin down to the belt to try to knock down any kind of contaminants or air that may be coming in or out of the booth. Here you see the first stage filters. They are in a metal frame with kind of a hook together. So if you pull one out, it pulls from the back side of the booth. Those need to be checked on a weekly basis also. Your second stage filters would be your sealing filters here, also checked on a weekly basis. For the exhaust system, it's a little more complicated. We've got 4 stages of exhaust on this machine. The reason being, it has the capability of taking some of your exhaust air, a certain percentage, and bringing it back into the booth as intake air. So we have to make sure that all the particulate is removed from the air in this case. So here we see the accordion Andrea filters. It's our first stage filter. It's going to get a majority of our particulate from the exhaust. Below, we have a second stage filter. It's a poly filter, similar to filters in a manual spray booth. Second stage filters are in a frame, so the material can be ordered on a roll and cut to size. Here we're panning around and seeing the third stage and fourth stage pocket filters. So these are the ones that are really taking out the very fine particulate and making sure that we have almost no dust or anything getting back into the intake side of the booth. If these filters are neglected or there's a hole in the filter, we'll have particulate escape through, and it's just going to clog up our intake filters that we saw on the top of the machine quicker. Next, we're going to talk about lubrication points. This machine is equipped with an automatic oiler. The oiler has a cartridge of oil, which we're going to see. The software keeps track of how far the arm has traveled, and at a certain distance, it's going to throw up an alarm on the screen in which an operator will push a button, and it automatically shoots an oil. So this is kept in a log. So if maintenance teams or management want to go back and check on the maintenance for how often it's been oiled, and it's all logged. The filter cartridge holds enough oil, we've been told, to last probably 5 to 10 years depending on use. So it's not something that's going to be replaced very often. And there you can see the oiler. This machine is also equipped with a water separator. This one actually has a cartridge inside. You have a gauge at the top that shows you the life of the cartridge. So when the needle on the gauge gets to the red, it's time to replace the cartridge. Reclaim system on this machine is a Teflon cross belt. The belt comes up, makes contact with the transport belt. The cross belt, then it brings the coating laterally to a V-scraper, and a V-scraper engages the cross belt and will train the coating into a collection bin. There are also guns mounted on the belt to add solvent to it to aid in cleaning the belt, keeping it wet, and to also in viscosity control to be able to use the reclaim that you're coming off of this belt. So if you'll notice, this belt is a little bit angled in relation to the machine or the cleaning group, and that's to spread the contact point of the main roller here so that we have a wider pattern of paint that's being brought down the belt to the V-scraper. The V-scraper blades traditionally have been shipped with a stainless steel blade. That's very important that on a daily basis this blade is checked, because depending on the abrasiveness of the paint you're using, this blade will develop a sharp edge. Once this blade develops a sharp edge, it will start to damage and shave down the Teflon. So it's important, if you have a metal blade, to check it daily to make sure that we don't have sharp edges. It's also very easy to replace that blade. A couple of bolts and you can replace it. So the latest generation of machines in the last year or so have been shipped with a black plastic blade, and the plastic is not a problem. You don't have to worry about damaging the belt or keeping it dull. So here you see the black plastic blade actually. Cross belt guns. These are the guns that apply solvent to the belt to help with keeping the V-scraper clean, along with controlling viscosity um, in your reclaim. These are supplied by a fairly small line, 6 millimeter, which is a 1/4 inch line or smaller. It's important to make sure that the tips do not clog up. Clogged up tip, you run for a couple of hours, can accumulate on the V-scraper. You can develop a wad, and then you'll have to stop and clean the belt. So check periodically every break when the machine is stopped for production, stopped for a few minutes. You can check the pattern just by pushing these buttons right here. You can manually fire the guns to make sure that they're spraying. So for the cleaning group is another aspect of the machine that the software throws up an alarm and says, hey, check me, see if I'm clean. So at a 4-hour interval, the software will ask for the cleaning group to be swapped. Because this machine has 2, if you're running with cleaning group 1, cleaning group 2 can be engaged. 1 will drop down, and that allows the operator then to pull it out, wipe it down, and clean it. It's important on a daily basis to inspect the blades to see if there's any buildup or wear or damage to the blades. So here we are pulling out cleaning group 1. Here we can see the blades. We have the first blade and second blade. Solvent is pumped into this channel here and here on both sides, here and here. Roller is turned, so we have wet solvent on the belt. The blade is first blade is really responsible for cleaning most of the coating off the belt. Second blade is really responsible for drying the belt. So we have options where this can be metal or rubber or both or carbide, and the back one is always rubber. So we have to make sure that we don't have any wear or defects in the blade, which would translate over to a wet spot on the belt. If we have a wet spot on the belt, then it can transfer to the bottom of your parts. Okay, now we're going to get a little bit into the pump and gun section of this. So the very first aspect of the pump we want to talk about is the main filter. So every high pressure pump should have a filter right at the pump. And the filter could be varying meshes, but it should always be one mesh size smaller than the tip you are using to spray with. This filter needs to be checked minimum once a day, particularly if you're spraying different coatings through the same pump, because you can accumulate buildup, you can accumulate contamination on this filter, which will translate into less flow, and it will very quickly damage this filter due to the pressure of trying to push coating through it. It will actually split. So here's an example of a dirty filter. It's the housing for the filter. You can see buildup inside. And this is after we cleaned it. So this filter is your first line of defense for tip clogging. If you maintain this filter on a daily basis, your life will be much easier. Next, we're going to touch on oiling for the pump. Different brands have different positions for the oil. Some have a cup, some have a sight glass like we see here. But it's important that oil is in the pump, and it's important that the oil is still good. So visually, once a month, at least check the oil level. You can see here with the red arrow in our sight glass, this is for the piston oil. If you see a sudden discoloration of the oil, it changes colors or something very drastically, could be a good indicator that we have a seal issue going on. So It's we need to address that because then you could get oil contaminated into your coating, which is going to cause fish eyes and all kind of issues on your production parts. Over time, when the oil becomes very, very, very dark where you cannot see through the sight glass, it needs to be drained and refilled. So taken down, laying on its side, unscrew the plug, drain it out, and then hang it back up, and then refill until you're at the level you see in the picture. Additionally, some pumps have oil for the lubricating, the reversing valve, and such inside. So in this particular picture here, you see a cup with oil. We have a needle adjustment on the top. We can adjust how much oil is being added into the pneumatic line for oiling those components. So periodically check to make sure you still have oil in this cup for lubricating. If it drains very quickly, if you're seeing that disappear within a week or so, there's a little flathead screw in the top needs to be screwed in so that the amount that's released is much less. So spray guns. Spray guns are probably, in my opinion, the most maintenance dependent item on the machine. They require the most attention and have the biggest effect on the quality of your product you're producing. So on a daily basis, we recommend soaking the tips and caps in a compatible solvent. So acetone, butyl acetate, if it's a solvent-based coating. If it's a water-based coating, then water. But soaking the tips will prevent coating from drying hard in any of the orifices or any parts of the cap or tip, which then will make cleaning more difficult. Also, it's good to track the hours of how long you sprayed with your tips. Over time, the orifice starts to wear out and your fan pattern will change, and it will cause a different appearance and could cause striping on your part. So you want to make sure you keep track of how long the tips are sprayed. Secondly, track how long the guns have been in use. So if you used the gun for a year and you don't have a backup on the shelf, you need to schedule time to rebuild the gun. It's something that you don't want to have fail on you and you don't have a backup in place. So if you have backups on the shelf, rebuild as needed. If you don't, then try to schedule it annually, if not sooner. Here's what I touched on the tips over time through wear. When the tip's brand new, you have a nice wide pattern. As the tips wear, the pattern starts to get shorter and fatter. So here you can see when it's worn completely, we're down to just a circle. We lose our width. So this would cause striping pattern on the machine, as well as more coating being applied because the orifice size is bigger. When you clean your tip, you'll always notice there's normally a slot cut across the tip for the fan width. So we recommend with like a nylon brush, non-metal brush, with a compatible solvent to clean the tips frequently. Anytime you stop spraying for more than 5 minutes, if you're going on break, if you're going to lunch, if you're going to a meeting, stop, brush the tips off, and then when you come back, you shouldn't have to worry about dried tips and have to worry about cleaning tips because they should be clean and ready to go. So always brush in the direction of the cut on the tip to help keep from building up coating in the slot and distorting the fan pattern. Another important point are cleaning needles. Some people use them, some don't. The cleaning needle is a tapered needle, very fine, that can be used to remove clogs and debris stuck in the tip. So because it's tapered, you always want to insert the needle from the back of the tip and never from the front of the tip. Doing so can open up the orifice and you'll go right back to the problem we just saw with the fan pattern starting to degrade and get rounder. So this will wear your tip quicker. And it also runs a risk of breaking the tip off inside, which I've done a few times. right, that's it for me. Questions?
Perfect. Thank you so much, Perry. I know coming from the marketing side of things, I learned a lot in that as far as the maintenance of machines and caring for things. So I'm guessing that all of our attendees probably have learned quite a bit as well. I'm going to give everybody a couple seconds here to submit questions. You can use the chat function or use the Q&A, and just want to share a little bit of information. Additionally, if you do have questions beyond this session, please contact us. Perry is a member of our technical support team. End up talking with him on the phone or over the email. But here's our contact information. Feel free to take a screenshot, take a photo of this, keep it on record. The technical support team is available 24/7, regular hours 8 to 5, and they're going to have answers to all of your questions beyond what was covered here. Additionally, we have product specialists spread throughout the country. These folks have numerous years of experience within finishing, with a strong understanding that when a customer is looking for a finishing machine, it's not just a drag and drop and place it in a factory. This team consults with you, works with you, understands the products that you're trying to make, the finishes you're trying to accomplish, and will work with you in whatever situation you have. So just wanted to give a little shout out to that team. They're also obviously backed by additional tech support and service team members. And you know, we have a lot of experience here at Styles. I did want to give Andy a chance to share some information as well. Andy was who you saw in a lot of these videos that Perry shared. Andy, go ahead and jump in.
Okay, thanks, Andrew. One thing I wanted to mention too, when Perry was reviewing the cleaning of the tips and caps, the ultrasonic cleaners that are available on the market are a great option for cleaning those. Those of you that have them or have used them in the past, one thing I want to point out is that you never want to leave the tips in that solution overnight. Depending on the makeup of those caps, particularly, the solutions that are normally used in the ultrasonic cleaners will start to pit and deform your air horns. Once you start this, it's going to affect your spray pattern as well. So any damage that's done to those air horns can affect the spray pattern, again, whether it's through dropping, the pitting that you might see if you leave your tips and caps in that solution overnight. Things that you want to avoid are damage to those air horns. So just wanted to point that out as well, that any deformation there can create issues.
Awesome. Thanks for sharing that, Andy. It's a good update. Do have one question. I don't know if Andy or Perry, you want to tackle this, but question comes from Kyle. What are the pros and cons of different types of scraper materials in a belt cleaning unit?
Yeah, I can answer that. Depends on the coatings being sprayed. So in a situation where we have coatings that dry very quickly on a belt, we tend to try to use a firmer metal type of blade, carbide, stainless steel, because if it dries fast, then it's going to be harder to clean from the belt. So that situation, we would prefer to use the hardest thing we could to remove, but we don't want to damage the belt. The second scraper, being rubber, should always be rubber, because we need to keep the belt dry. So the first scraper is going to do the cleaning. The second one will do the drying. So hope that answered that.
And as Perry pointed out earlier, that second blade, as it wears, will become rounded. So the changing of that rubber insert blade will be more frequent than the metal first blade, just because of the friction that's put on that rubber. It's designed to work as a squeegee, as Perry said. So it's a softer material designed to dry. So that insert will wear and become rounded, somewhat deformed more rapidly. So the condition of that blade needs to be monitored on a more consistent basis just from that aspect.
I think we had a follow-up question, Andy, for the comments you were sharing. So leaving it for 10 minutes to clean is fine. I think that was in regards to talking about
ultrasonic
cleaning the
cleaner.
tip. Yeah, yeah.
So the ultrasonic cleaners normally have a cycle time on them. They have a timer. So you drop those in there, it heats and excites the solvent bath that it's in. So as it goes through its cycle, that's fine. Some have a 15-minute cycle, a 10-minute cycle, whatever is designed for that system. Anything, again, beyond that, a 30-minute cycle time is not bad. It's when you leave them overnight repeatedly. As Perry had mentioned, if you soak them, it's fine. It's the ultrasonic cleaner solution that normally shows that wear and damage more so than just soaking it in a diluent that is compatible with your material. So if you're using a solvent borne and you're soaking it in acetone, you won't see it so much. If you have a waterborne material and you're soaking with water and a water and acetone blend, you're not going to see it. It's the ultrasonic material that's used in those cleaners specifically that will cause those to pit.
Awesome. We had a comment way earlier, back in the first couple of slides, Perry, when you were talking about some of the filters that we thought was really interesting. And I said, my spray starts looking like orange peel when the filter needs replaced. I don't remember which filter it was, but thought that was a really interesting way of picking up when you might need to do some maintenance.
Yeah, so he was referring to the pencil filter, I believe, Perry. So yeah, anytime that filter becomes clogged, you're going to affect your spray, whether it is in the amount of coating that you're getting down, or if you're filtering out some of your solids, because that filter is somewhat clogged, you're going to take out some of your solids of the material. Your build might not be as much. You might get as many wet mills down, but you're just getting more of the vehicle rather than the solids. So your film weight might not be, your dry film weight might not be the same as you evaporate off your vehicle. So anytime you see a variation in your spray pattern, if it's not a tip related issue, it could be from the filter. So you'd always want to clean that when you are seeing a problem that normal tip cleaning doesn't solve.